Okay, I want to say this now because I don't know that I'll remember to say it in class, but I didn't say this for the first unit, and so I didn't make you do this, but from now on, when we have a test, you have to turn in all your notes and assignments. So you need to keep track of those, whether it's in a binder or folder. Hopefully I'll remember to say this in class. Hopefully you're listening to this video so you hear this too. But make sure you're filling out the video notes and make sure you're keeping track of your assignments, okay? Label them. So day one of this, we just reviewed graphing linear systems. Now we want to look at like what if there's more than two equations. And so this one has four, right? So it says sketch the solution set for the given system. And there's four different equations here. One, remember that we want to put them in slope-intercept form if they're not. So y equals mx plus b. The first two, x is greater than or equal to 0, y is greater than or equal to 0. Those are just vertical and horizontal lines, right? X equals 0, or x equals a number, is always going to be a vertical line through that number. And y equals a number is always going to be a horizontal line, because this one has undefined slope, and this one has 0 slope. So x is greater than 0 is really just starting at 0 on the x-axis, and it's just the vertical line. It's just the y-axis. Y is greater than or equal to 0. That's going to be this way. And notice I'm not shading yet because I got to figure out where all these intersect. And so I'm going to wait to do that till the end, okay? So the next ones, I'm going to put them in slope-intercept form first. So what am I going to do to put this in slope-intercept form? I'm going to add 6 over and subtract x. So I'm going to get negative x plus 6. That's going to be a y-intercept of 6. I'm going to change colors. And a slope of negative 1. And I'm making lots of points because I want to make sure I get the intersection good, right? And a good thing this is a solid line because I forgot to check. Last one, also, I'm just going to add 8 and subtract 2x. I'm actually going to change to green here. So this one has a slope of negative 2 and a y-intercept of 8. So then I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Also a solid line. Now, I think it's going to get really messy if you do all the shading. And so what your book recommends, which I actually kind of like, I'm actually going to change this one to black so I can have 4 different colors here, okay? Is they just kind of draw some arrows above each one to think about it. So x is greater than 0 is my red line here. And greater than would be like shading this direction, right? So they draw little arrows like this to say, hey, I'm shading in this direction. And my black line here is y is greater than 0. So I'm going to say greater than would be above this line, right? So if I was just shading where those overlapped, it would be like everything in the first quadrant here. If I switch to my blue line, which was this equation, even though I wrote it in red, everything less than that blue line would be going in this direction, right? So now it's definitely closing in on my area. And then the green line is also less than. So think about where I want to shade. I want to shade everywhere that it's both below the green line and the blue line, but greater than the red line and the black line, which I think I'm going to change to crayon here so you can still see it. I think that it would be this area here, right? Everything in this little trapezoid. And we're going to continue with this in later sections and talk about what we can do with a shape like this, what kind of story problem we can solve using a shape like this. But for now, we just want to think about being able to find that and kind of noticing that we have these points. We call these corners of this graph, and that region becomes important later. So look at this. It says, using this, determined whether the point 1, 3 lies in the solution set. Well, if you have the graph, you can look. The point 1, 3 would be right here. And yes, it would be in there. You could check that the 0.13 satisfies all of those conditions. And what about the 0.53? 1, 2, 3, 4, 5, 3 would be out here. So this one would be no, it's not in the shaded region. Okay? 5 minutes. Okay. Big idea, again, that we're going to use later with this is that the shape that you get is called a feasible region. The feasible region, okay? And what happens is that when you graph these, like we just did, sometimes you get a closed shape, okay? Or the word that we use is bounded. And when you have a bounded shape, you can find a max or a minimum. Again, we're not there yet, but that's what we're going to do next. And that's always going to occur at one of these corners of your feasible region, okay? Sometimes what happens is it's not bounded, which means look like this. If you had 3 lines here, these did not make a closed shape, and we call that unbounded. And it could have a maximum or a minimum, but it's not going to guarantee to have it like the feasible region did. It still has some corners here, but it also keeps going forever in one direction or the other. Still the feasible region, it's just not a bounded one. And your book describes bounded as you could draw a circle around it, and an unbounded one you couldn't draw a circle around because it goes on forever. Okay? So the last one I have here is a story problem. And this one's from your book. I almost changed this because in your textbook, it says Sonoma Company manufactures a 24-bottle wooden wine rack in 2 versions, and I thought you were going to yell at me for saying that in high school, but whatever. It's a college course, right? It doesn't matter. We're just building wine racks. They have a standard rack and a deluxe rack, and it says each standard rack requires 12 minutes of fabrication time and 4 minutes of finishing time, and each deluxe rack requires 8 minutes of fabrication time and 16 minutes of finishing time. There are 6 hours of time available for fabrication and 8 hours available for finishing. Write a system of inequalities that gives the restrictions placed on the number of each type of wine rack manufactured by Sonoma. So again, with story problems, we have to think about what our variable is, right? And I feel like our variables are standard rack and deluxe rack. Does it matter which one you call X and which one you call Y? I don't think so. But I would say I'm going to let X equal the number of standard racks and Y equals the number of deluxe racks. What's kind of tricky about this is that we have 2 things going on, right? We have fabrication time and finishing time. And we also have minutes and hours. And so we have to convert that. We have to either all be in minutes or all be in hours. So I think it's easier to convert to minutes, and so that's what I did. So think about for fabrication. For fabrication, the standard rack requires 12 minutes, and the deluxe wine rack requires 8 minutes. And we only have 6 hours of fabrication time. So that would be 6 times 120, right? 6 times 60, sorry. Which would be 360 minutes, right? What sign should go here if I don't have more than 6 hours? You might say it should be equals to 6 hours. But, maybe you finish early. So I think it should be less than or equal to 6 hours because you can't go over 6 hours. And for finishing time, 4 minutes for the standard one and 16 minutes for the deluxe one. We have 8 hours, right? So again, I think it should be less than or equal to. So that's definitely a system. Look at part B, it says graph this. So I want you to think about what we could do to make this easier to graph. And we'll pick up here, okay, it's only 9 minutes. Well, that's okay. We'll pick up here in class. Maybe you could try to simplify this a little bit to make it where we could graph it.